All right, let's check the volume. Let's see if you people can hear me. We got volume. Great. Hello, everybody. It's Chris with Click Team. Today we're going to wrap up our for the Reactor our level streaming code, and then by popular request we're going to work on zooming, and then after which we're going to play a game that I had no idea was made in Fusion, and it's probably the hardest game ever made to play. It's pretty cool, so we're going to check that out too. So yeah, what we started with last week was level streaming, and the level streaming source that I'm going to post up comes in two parts. It's the editor, and what the editor does is allow us to currently open up a level. So we could say new test, and you get a level layout, or you could open up a different one, and it stores the entire level data in an array file. And what it does, as we mentioned earlier in the array file, each 32 by 32 bit square right here, this is in the array location 22, and this is location 1 1, 1 2, so forth and so on. So that's 2 2, 2 3, 2 4, 2 5, 2 6, and so forth. Actually, I got that wrong. This is 2 2, 3 2, 4 2, 5 2 because it's XY. And then when we save it, it saves those numbers in the array. If there's nothing like here, then it saves a null, a 0. Again, remember in an array, when returning in a numeric array a null value, nothing, you get a 0 in the editor. And that's important because each one of these objects has a tile number, and you can see that none of them are 0. And that's on purpose. You could go 0 base, but then it would show up as a null set when we run the level streamer. So the level streamer now is working 100%. We can run the app, and you can see that currently there's 172 objects. Now if I was to deactivate the streaming and set local values, we'll get a total number count. And no, that didn't work right. So it's saying there's 280 objects. So let's check. And that is correct. There are exactly 280 objects here. But with the level streaming on, you can see now that we only have 172 objects. And that number fluctuates depending on what's popping in and out of memory using the array. So it's working 100% solid now, and I'll go over again real quick how that works. So what we do is we first load everything. In the first iteration of the engine, it loads everything. So if we look at our list view editor, we can see that on group activation, we load the array file that has been selected, in this case test.arr, and then we scan the array for how many columns it has, and we run dimension x based on that, load level column, dimension x times, and then on each load level column, we load level rows based on dimension y. And then as it's reading the rows, it is reading each individual cell based on the current load level column, and then on the load level rows, getting us that XY. So this is XY, and it's based on the many times it loops. And we're pulling those loop indexes numbers for those XY positions. So on loop lead level rows, if it equals 1, if that particular cell we're reading equals 1, then we're going to create a box, and we're going to set the X and Y position of the box based again on those XYs, and we're going to multiply it by 32. Because remember, when we built the editor, we snapped to 32-bit, 32 pixels squared, and we then divide by 32 to get it down to 1, 2, 3, 4, 5, so that it fits in the cells. And then we do that for load level 1 and load level 2 for the grass tiles. And then that's how we load the levels. And so it builds everything. In this iteration, it's building everything. Then we get to the engine, and here we're centering the display on our guy, and you can see that I'm setting my two strings. One is behind the other black to give it that shaded look right there. So just generic stuff. And then this is collision between foreground scenery, which is set to this particular object here. And then this object, which you can walk on top of, is not scenery. So that covers those events, nothing major. Then here, we're setting the local values. So we have a local value object, which you may be familiar with from the last demonstration. And I declared these variables, these alterable values. I got a left visible edge, a top visible edge, left bounds buffer, right bounds buffer, top bounds buffer, and bottom bounds buffer. Now, what does all that mean, right? So here's a little mock-up I did. When we run the game, this area is what we see here. And as we move along the screen, we're sliding this through the entire frame. Now on the outsides of that frame, these are the buffers. So this would be the buffer zone. Actually, the buffer zone's right here. So that determines the buffer zone. Anything in the red, so if an object, as I move this direction, the objects that were here slide out this way, and if they enter outside the buffer zone, they're deleted. So the red represents the delete zone. So anything that slides out of the area is deleted. Anything in the green remains. Now these right here are our buffer render lines, and everything's based on 32 by 32 bit. You can scale it however you want in your own engine, should you download it and try to mess around with it. But as you can see here, if the position of one of these objects, these two tiles, both share the same group, which is, I believe we call it group obstacles. So if they're outside those different bounds, as you can see, we do the calculations, then we destroy them. Then when we're streaming them in, we first do the fast loop for streaming whenever the speed of the character is greater than 0. The character is currently just using your default 8 directions movement. So whenever the speed is great, we don't need to run the loops if the thing's not moving. We don't need to stream in and out any level data if the screen is not moving. So if the speed of our character is greater than 0, then we start the loop process, which in this case, we start with loop stream 1. And then we do a series of embedded loops inside of loop stream. So loop stream 1 runs, it runs this one event. So the only event that stream is on that I'm aware of is line 27. And then it runs these individual loops. Now you see that there's a outer and inner for both right, left, bottom, and top. And that corresponds to these areas here, which I've color-coded. And I'm going to include this all in the bundle. So for instance, when we start loop stream right outer, it then is going to determine what the left visible edge is, plus 14. So what that does is, it says, here's the left visible edge, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now we're here, and then for the Y position of the placer, it says give us the top visible edge minus 4 times 32, which then brings you up to 1, 2, 3, 4. So it puts it up here. So we start up here. And then as we loop, and you see that we loop that outer stream 17 times, that brings us down to here. So that's what it's doing. And because it's a fast loop, it happens in between the movements of the player. So a fast loop obviously pauses the main loop so that we're able to execute these with the very fast, with the engine kind of paused, if you will, nanoseconds. And then we run this loop. And the placer moves down, starting up here, down to here. And as it's doing it, it's then going to read two things. It's going to ask, is the placer overlapping another reference point? And again, these two tile types also carry the reference point tag. And if it isn't overlapping anything, meaning that that cell is currently empty, then we also read based on the same calculation that we're using to find the XY position. We use that in the cell to determine which cell we're reading. And you notice that we multiplied by 32 for position, but we don't multiply by 32 here. so that we get that 1 to 32 ratio when popping into the cell. And then here's where we iterate down along the Y. If there's no overlap and it equals 1, then we create that particular tile. And then the same here for 2. And then, as you see, this is stream right outer, and then stream right inner. And you can see it's 13 and 3. So that starts us here. And then you'll notice that the loop is 2 less, 15. So it loops down to here. And then each one has a different set where it may start here and here, here and here, here and here, so forth and so on. And then it reads all 4 of these areas, all 8 of them really, each loop as it's moving to determine if there's an object there. And because it's already doing the snap to, they snap right into position. So as we're running the game, it streams in that information as you move along. Now, just to test our theory here, we'll go to the editor. We're going to open test R, and we knew that it was very few objects. It was like 200 and some objects. So what we're going to do is we're going to write in a big amount of objects down here. And then maybe we'll add some grass. All right, and then we'll save. And let's load it just to make sure it worked. And my arrow keys are no longer working for some reason. So I'll just reboot it just to make sure that data was saved. File, load level, test. And it didn't write the data for some reason, so we'll have to do it again. File, save, test.arr, and then we can go into the folder where we've got that data. Reactor, source, world streaming. See, and then it's actually putting it there, so I guess I still have a bug. So file, load, test. We can do it like this. File, load. Okay. File, save level. Please work. Run it again. Load level. So obviously we have something wrong with my save routine, so let's go ahead and see if we can fix that. Save file name .arr should be working. And then let's take a look at the test file, properties, 449, February 2nd, modified 1 minute ago. So it is saving, but it's not saving the new data. That's weird. I wonder, is it an issue? Cursor's on the right level. Oh, that could be it. I'm wondering if they're being destroyed out of memory. Let's find out. File, load level, test array, scroll down, add ridiculous number of guys, file, save level, test, okay, run it again. Well, it looks like I got an issue there. But anyways, the end result is complete control. Now look, see, now the level's all messed up because I've got objects missing. Let's see if we have any questions on that. No questions there. No questions there. So the other thing we wanted to work on, so I'll polish up the editor. I don't know what's going on with the editor, and I hope to have that posted this weekend. That being said, I'm going to close it, and we're going to work on zooming. Everybody wants zooming. So I did some experimentation, and based on work I had done on a different game, this game here, Noble Armada, I have zooming in this game, but I didn't have zooming that allows you to move while zooming, which I thought was important to add, so that's what I modified it to do.
Your will be done.
Alright, so there we zoom out, and we zoom back in. So the way this works is all these objects share a global value, a global qualifier, if you will, and we calculate the center of the screen. And what we do is we manipulate everything based on the center of the screen. And it's actually not that complex. So let's do the basics. Let's first start with a ground tile. So here's a ground tile. Let's put one in the corner here, one in the corner there, one down here, and one here. Now this tile already has a preset qualifier, which is reference points. And then we're going to grab another object, we'll call it player, try to get in the middle. And the player also has the qualifier for reference points. And then in addition to that, each of these objects share the same two alterable values, current X and current Y. So let's go into our code, our event editor, and let's code up the first line. So the first thing we do in the event editor is at start of frame, we're going to set position. And we could do it under the qualifier, but I'll do it under the individual objects for now. So we'll say alterable value set current X to the current position of the object. Then we do the same thing for Y, setting the current Y to position Y of the object in question. So you get that. Now, we also need to do it with this guy here, and then we got to go ahead and make sure that we're pulling the right data. So the old drag and drop there. Boom. Okay, and then what else do we need to do? I think that's about it for the start of line frame. So insert comment, set initial position in object values. Great. Then we got to have a line which will be our zooming calculations. And this one we're going to set to always. Yeah, I'm actually looking at code that I wrote earlier. So we'll set this to always. And then we got to get a new object. We're going to get, well, I'll just pull the one I already have. Zoom local values, right? So the zoom local values, I declared 4 separate values. We're going to focus on the first 3. Zoom factor, which is default to 1 because everything's 1 to 1. When we run the game, that's a 1 zoom ratio. And then we've got screen center X and screen center Y. The first thing we have to do is calculate screen center X and screen center Y, which is really not that hard. You just go here, start by setting the right value, and then we just say X of right frame divided by 2. And the reason we do that is when we add a bigger frame, we're going to scroll, and then this border will change. Currently, because it's 640, we're going to get 320 when we return that value. And we can double check that by adding the object to the debugger and run it real quick. Go to our debugger, ultra values, and see 320. And since it's 480 high, we should get 240 when we set the other variable. Set screen center Y to bottom. What is it? Bottom. No, it's Y bottom. Y bottom frame divided by 2. So now we're going to calculate from here to the center by dividing it 2, and down from the bottom to the center 2. And if we look at our values, in fact, that's the data we get. So that's good. Now the next thing we need to calculate is scale. Not very hard. So we calculate that in the reference points, and we say scale, set scale, and we take zoom factor, and we multiply that. We actually just add 0.01 as a little offset to make sure it's scaled right. So as this number changes, it will change the scale. And we're going to go with maximum quality because we're maximum quality kind of people. And then we have to scale the X and Y positions, set the X and Y positions. But before I do that, let's go ahead and add the manipulation of the zoom values. So let's go here, and we'll say manual zoom control. And then we're going to have 2 events. Repeat while the plus sign is clicked or pressed down. And if it is, then we're going to add to zoom factor 0.01. Okay. And then the same thing for minus. We'll subtract from that value 0.01. So let's see what happens just to the size of the objects. As you see, they increase and decrease in size. But now we need to relate them to the center point positionally. So then we go back up to here, and then we're going to reset those positions. So we start by setting X position. Okay? And then what we're going to do is we're going to set the X position based on the screen center X. And then we're going to subtract screen center X by screen center X, because we have to offset based on the values that we have in the object itself's current X. Okay. And I believe I can get away with that. And then we multiply that by our zoom. And I believe we need to encapsulate that all into its own statement. So this executes first, and then it subtracts it from there. So let's run it. And as you can see, it is now scaling correctly along the X. Now we have to repeat that process for Y. And we'll do it the easy way. We're going to copy that. And then we're just going to go here, position, set Y. And then we change our values around to match Y. Why? Because we love you. And then we run it. And now you get that scrolling effect. So before we continue, let's see if there's any questions. So Joshua was asking what we're working on. We're working on a zooming effect, zooming in and out. And appreciate you watching. And of course, everyone wants to know when Click Team Fusion 3 is coming out. It's going to be longer than a couple minutes and sooner than the next century. That's about all I can tell you. Yeah, so thanks for watching, guys. We're going to work on scrolling now with the zooming. That's a great question, Jeff. I haven't noticed any gaps. We'll look at the next level so you can see. I haven't seen any gaps because scaling and the positioning, you would think that it could have an issue because positions are X, Y, or integer based and not float based. But I think the scaling, especially when we scale with that plus 0.01, that causes just enough overlap to prevent any gaps. If you find gaps, you could increase that number. So I hope that answers the question. Thanks for asking, Jeff, and I'm glad you're here. So how do we make that a little more complex, right? So then we've got this demo, which I've put together, where our guy's walking around. And I've added a map function, so it zooms out, and you can zoom back in. I also added a zoom for the battle. The question is, how did I do that while moving? Well, it's really actually not that hard. So what I had to do is when moving my character, I had to actually reposition them here. So when you're moving your characters, you don't actually use a built-in movement and move the XY position when using this method. You have to actually manipulate that current X and that current Y, because that's the position of the object is now based on that value and not based on anything else. So if I was to take this code here and move it to our simple example, I'm going to get some errors because I don't have these objects, which is fine. We'll just remove that. That, and then we'll do that because I should have done it that way. And then I want to clone this because I want to keep the basics the basics. And we'll call this scrolling. We'll go back to basics. We'll pull this out, and we'll go back to our scrolling. So now when I move the character, using the arrow keys, character moves. And my zoom still works. And I can move while zooming. Cool, but now we're not scrolling it, right? Well, believe it or not, scrolling does not become that hard. At this point, it's simply a matter of saying, make the frame larger. And then we've got to center the screen. So centering the screen is not that hard. We're going to center the display of the screen on our character. On the always event, position on character. And there you go. That's all there is to it. Now, is it the prettiest version? No, but this is just a down and dirty. You'd want to tune it for your game, your engine, whatever you're trying to do. But yeah, that you can do. So let's look at the audience and see if anybody has any suggestions so far. So I got that, and then I moved on to this, which gives us the map by hitting the map key and zooming in real fast. And you can move, collect the coins, but then you have this little attack animation. And then on the next one, I decided to say, what would happen if we moved more roguelike, so you can tap and move a single direction. That red line, there's actually a detector that prevents me from walking into the walls. There's actually two detectors, a red one and a yellow one. The yellow one will make visible just so you can see it. And that's how that works. So let's see if there's any questions. Yeah, that's what saves you on the overlap, is that little, just that little bit 0.01 overlap. So Happy Orange wants to know why we don't use the lens shader to make a zoom effect. That's a great question. Well, shaders are A, resource intensive, and B, they're not cross-platform. And I don't know about you, but when I write stuff, I try to make it as cross-platform as I possibly can to have as many markets open to me if I'm doing something commercially. You know, what works shader-wise on iOS doesn't necessarily work on, Android. Yeah, I'm sorry, PC versus Android, PC versus iOS. Fusion 3 should be shader cross-platform, so we're pretty excited about that. But in the meantime, got to work with the tools we got, and if I'm going to do something on one platform, I kind of want to do it on the other. So I try to do everything cross-platform. Hope that answers the question. So another thing I thought would be cool is if when he moved, because it's moving kind of slow right now. It's kind of a drag. It needs to be a little zippier. So how would we do that? Let's take a look. Get back into our code. This is where we're moving stuff. So what if we, instead of doing it on a flat number, what if we did it this way? What if we said subtract 2 from adjust x? So how would we do that? So we could subtract adjust x. Where do I have adjust x? I'm looking at the wrong object. Here we go, value. So if I did that, we put that on the end, it would pop instantly. Let's test that. Right, and then it just, well, it looks like he popped twice, didn't he? So that's not good. Perhaps because so here we adjust to 64 and we subtract 64 immediately. And then the last thing is we subtract 64 from 64. It should equal 0. So we should see if our values line up first. So there's the player, there's the algebra values. Sliding the one direction does exactly what we thought it would. Okay, so the issue is the repeat. If I just delicately tap, yeah, see, it's the repeat issue. So that's fine, because we're going to correct that anyways. Because we don't want it to pop. What we do want it to do is divide by 2 and then plus 1. Maybe we can just go plus 2. Let's see if we just do that. Yeah, so now that's nicer. Of course, we're not able to go back for some reason. Wonder what oh, I bet you are. See, our adjust x is in the positive, which is what I was afraid of. So that means I do need the plus 1, and we got to worry that we might end up in the negative. So let's find out if that happens. Because when we divide, we end up with a potential float. There you go. And let's double check our values. Oops. Boom. So now we got to repeat that same process for the add. So instead of add adjust x, we're going to add value. Oh, wrong object. Always doing that. Adjust x divided by 2, put it in brackets, add 1, copy that bad boy. We got to put that on the bottom now, and then we adjust here. And let's see if that works. Oh, something went wrong. Maybe it needs to be -1. Well, let's see what happens. Let's put our guy in the center. It just keeps on going. And he's off screen. Look, he dropped from memory too. So we can see what we're dealing with. Let's keep him in memory. Expose his values, and then go for the directional movement. So, did you see how he went in the negatives? Interesting. Maybe because I'm dealing with a negative number. Just for giggles. As I try to think my way through it. It's kind of cool though. Yeah, when you're doing Joshua, when you're doing the 4 directions, if you're doing just 4 directions, and this actually works for 8 directions, you're only going to ever move in collisions, and you can't go up and down at the same time, and you can't go left or right at the same time. So you really only need 2 objects. There are ways to do it with 1. I just did it with 2 because it's easier. The only downside with doing it 1 is you have to lock yourself into a 4-directional mode. So if we go back to this version of the demo, and we turn these on visibly, so right, left or right works fine, right? And I can't hit both left and right at the same time. I can only hit one or the other. And then down works fine, right? Down works fine. But if I was to do a diagonal and only had 1 object, I couldn't have 2 objects check. So that's the reason for the 2. Hope that answers the question for you. Cool. Well, I'm glad you picked that up. All right. So, trying to figure out this other bug here. It's irritating me. Oh, no, thank you. All right. Weird. Okay. What if I made it a absolute value? Let's see if that does it. Because it may be adding a negative number. Because it's moving into the negative, so it must be consistently adding a negative number. And if you add a negative negative, you get a bigger negative. I need a positive number. So perhaps by dividing a negative number, I'm getting a larger negative number. So an absolute value might be the solution there. And let's find out. That was it. Of course, it's not going back the other way for some reason, so let's take a look at our player's values. He's stuck on -2. Fair enough. So then maybe it's -1. I've been having the worst time with my mouse. Seriously. All right. Still no good. Now it's negative some really strange value. Okay. So then what if we say absolute value just the way it is, and then close the parentheses and plus it there. Oh, this mouse is really irritating me. There we go. Still got a weird value. Weird. That's good. That's not good. Well, then maybe I take this and conversions, float to integer. It's probably an easier way to do this. That's it. So by converting, we dropped off that 0.0067 when we converted it back to a integer. Oh, so there we go. Oh, geez. Okay, now we're on the focus, and we're good. That seems to work a little bit. Now the camera's kind of jerky, isn't it? So now we're gonna have to fix that next. So let's repair the rest of the statements. So we're going to need that when we're going into the negatives down here. And let's adjust Y. Yes. Yes. Yes, sir. Yes, sir. Now that's for going up. Good. And then we use the same formula for going down. Move that to the bottom. Adjust Y. Copy. Paste. 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 Wonderful. There you go. Now, how do we make it not look like that? Right? I don't think that'll be too hard. So we're centering the camera currently on our character. I believe that happens on our main line right there, yes. So what if we create a new object? Heck, we could use this object here. So let's put that right with our guy. Okay. So he is 160, 160, 160, 160. Okay. So he's there. And then we're going to put the camera on it relative to our guy here. Run it. Obviously nothing's going to happen yet because it's not moving. Map still works. And he's moving around. Now, okay, so then what if we just said, using the similar formula that we just did, if we said position X is lower than position X of our guy, then we could set position X to position X minus position X, which should snap it there immediately, I think, if I did it right. Sort of. That's weird. Is it because... Okay, good, the qualifier isn't there. Oops. Did I get it backwards? Whoa. Weird. Or is it because... Alright, well, I want to do it a different way. Which will require me to get this fun guy here. And the way we'll do it is we will give this guy, just do it the cheap way, bouncing ball movement. And then always direction, looking direction of the player. So if we do it this way, it's going to do that jumping business, which nobody likes. So now we got to fix that by saying movement, set speed, and then we'll say direction between 2 points, and that's not direction, it needs to be distance, sorry. Okay. And then, I don't know if you guys know this, it should work here, but pull the position, and then just hitting the tab key highlights the next one for you, so you don't have to re-highlight it, which, you know, that's always fun. Alright, and then we're going to, on top of that value, we'll add a 1, because we want to be able to get 0 speed. So now it's not jumping. Now we get a much smoother scroll, which is what we were after. That's much less jumpy than it was before. And then we simply make this invisible so it doesn't interrupt our game. Yes, that scroll's a lot smoother, especially when I hold it down. wonder why it's not letting me pick up coins. What's going on there? Sorry, guy. Am I going the right way? Yes. Weird. That should be a simple. I wonder if it's on a different layer. I bet it's on a different layer. Yep. See, layer issue. Debug complete. I was playing with layers earlier. I should probably fix that by doing that. Oh. What's it doing? It's doing something weird. I bet you it has something to do with the zoom. That's exactly what it is. So we should probably fix that, huh? Easy enough. That should be super easy. Do a comparison. Zoom factor equals 1. If so, center display. And look. Auto value. Movement. Direction. Select direction. Nope. Look in the direction of the player. Wonderful. And then we got to have that set speed. Where is that? Where's my set speed event? I must have deleted it. That may be why it's not working. Almost hit. Man, this keyboard is driving me nuts, and this mouse is driving me nuts. All right, so we'll write it again. Movement, set speed. Look, the object's even gone. Was I on the wrong frame? Oh, the object was on layer layer 1, so that's why it's gone. Debugging, man, it's everybody's favorite time. Okay, so movement, set speed, and then it's direction. Direction. Oh man, it's distance. Did I do that last time? Learn from your mistakes, Chris. Okay. And then it's position X, position Y, position X, position Y, -1. There you go. Map. Good. Map out. Hits. Good. We're back. I got the gold. All right. Let's see if there's any other comments. Path movements. So you're asking Jeff if path movements are going to work. Yeah, that's going to be an issue. I'll clone it in a second. We'll try for you. But yeah, you have to control the movements now through that variable. You can't control it through the individual movement. But let's give it a shot. Doesn't hurt to try, right? All right. So let's save what we got so far, and let's take our scrolling example. Copy that bad boy. And then let's see, how would we move it with a... Now, when you say move by path movement, are you talking about the player object or a background object? I guess it doesn't matter, does it? Let's put a background object in. So we'll say that's the background object. It needs the global variable of reference. And then it needs its values current X, current y. Great. Now here, instead of setting these, we're just going to set globally. And before we do anything else, let's make sure we didn't break anything. And we're good. All right, now we got to try to get that guy to move on a path. So how do we do that? Let's see. Well, first let's give him a path movement. Let's see what happens. And we're just going to go across. And we'll loop in reverse. And you see he's not moving. And the reason he's not moving is because he is setting that current x and that current y based on this. So how would we fix that? I suppose we could update the xy. Potentially. All right. So new comment. Trying crazy stuff for Jeff. All right. Insert new event. Start with always. And then let's move this down here. And okay. Now, why is it acting weird? Okay. Well, because I need to do that. That's the first thing. We were updating all the objects. All right, so he zipped out of here. Did you see that? He zipped out of here. Okay. So instead of always, what if we put it on the actual plus minus? Yeah, I mean, he wants to move, but he isn't. So that's not the solution. Well, right off the bat, I can think of one easy solution. Is we could say clone, right? And we could then say 0, 0, and then we get rid of the path movement here. Okay, so now we know in the top corner we got this guy moving at 0, 0, which he doesn't seem to be moving for some reason. It's because he still has his qualifier. Okay, good. Now what we could do is then say always set current x to current y. Adjust x, adjust y, and then we could then say this, and then clone that. Then we could also change it to this. Or maybe we don't even do that. Maybe I don't do this at all. And then maybe I just say always set current x to current y by current x plus current position X. Let's see what that does. Still got the qualifier. Okay, and zooming works there. And then we turn this back on. And make sure I'm not duplicating the wrong objects. Let's give these guys some color. Okay. Give this guy, we only need to change one. Set current X to current X plus X. So it must be consistently modifying. So then I do need to go here, rather. Remove that. And then we'll set this to adjust X, adjust Y. Right? And then we'll set this to adjust X. And I put them over here for some reason. And I don't see my other object. Where did you go, friend? No. Oh. There we go. So it's close. How's that, Jeff? It's close. Let me know if you like it. All right, well, the final thing I wanted to do tonight, and I'll post both of these up this weekend, I'm hoping, the zooming code and then the level streaming code. The other thing I thought would be fun is I had no idea this was made with Fusion. It's a game called Trap Adventure 2. It's on Android and iOS. I played a little bit of it. It has got to be the hardest game I've ever played. It's almost comical how much it punishes people. And let's give it a shot. So first, let's figure out how to jump. So it's the space bar. I don't know what the P button does. All right. So watch this. This is unbelievable. So yeah, that makes sense. That makes sense. Oh, this must be an older version of the game. Oh. So you can't jump on that guy, right? So what you have to do is you kind of got to go like. It's going to be too hard to play on the browser, it looks like. So let's look up a video. What? Get out of here. So Trap Adventure 2. Just watching this first part will explain to you the difficulty of this game. Oh, okay. This is just the first level, mind you. Oh, no. Okay. Oh. No. Oh. What you gotta do is you gotta jump all the way over it. So give that game a try. It's It's hilarious. Trap Adventure 2. I'll put the links up on the Patreon. So I think that's it for tonight, guys. Thanks for watching. Log into the Patreon. Give me an idea of what you want me to do next, and I will do my best to do it for you. For those of you that need the address, there it is. And we look forward to getting these up and working on the next suggestion. Again, appreciate you watching, and this is Chris with Click Team, and this has been The Reactor. Talk to you later.